Hello friend, today we are going to discuss what we call second order linear differential equations. Now I want to look at case 1 that is talking about homogeneous second order ordinary differential equations. Now when we look at such an equation, dny dxn plus a1 dn minus 1 y the xn minus 1 plus a2 the n minus 2 y by the xn minus 2 plus dash dash up to an y is equal to x. X is a function of x, and therefore a1, a2, and an are called constants, and the above is a linear differential equation of nth order with constant coefficient c. Since the highest order of the derivative appearing in equation 1 is n, it is therefore called a differential equation of nth order, and it is linear. So if x is non-zero, for example, then the differential equation is non-homogeneous. That is, if this equation of a particular order is having a function of x at the end, this equation is called non-homogeneous as long as x is non-zero. And if x is equal to 0, then the differential equation is homogeneous. And in this discussion, we are going to basically look at homogeneous differential equations of order 2. So let us consider the differential equation the 2y the x squared plus p dy the x plus 2y is equal to x. We have said if x is equal to 0, then the differential equation is homogeneous. If x is not equal to 0, then it's non-homogeneous. Thus, if it is homogeneous, then the 2y the x2 plus p dy the x plus 2y is equal to 0 is a second order, is a linear second order differential equation that is homogeneous, because x, which is the function of x, is 0 or is equal to 0. So using a familiar notation of differential operators, we can say let d equal to d dx, d2 equal to d2 dx squared, d cubed, d3 dx3 up to the n, which will equal to the n dxn. Applying this to equation that is above here, it means d squared plus pd plus 2, we cross brackets, then we multiply by y is equal to 0, is an auxiliary equation or characteristic equation. In other words, it is just a general equation, it is the given equation, but when we use a method of using d operators, it is called d operators. So it means if we say let d equal to m, so that the characteristic equation becomes m squared plus pm plus 2, we cross brackets, times y is equal to 0. We must also know that y is never equal to 0. Therefore, it is only m squared plus pm plus 2 that is equal to 0. So this is now a quadratic equation, is a quadratic equation which can be solved using very many methods. You can use a factors method, very many methods. You can use a bulldozer method. And therefore, if we are to use the bulldozer method, whereby m is equal to minus b plus or minus square root of b squared minus 4ac divided by 2a. It means a is equal to 1 here, b is equal to p, and c is equal to 2. So if, for example, case 1, b squared minus 4ac because we are saying if we are to solve this equation, it will have roots m1 and m2. m1 and m2 may not be equal. Yeah. So if we say that b squared minus 4ac is greater than 0, it means this equation, this quadratic equation here, has got real and distinct roots. Then the general solution for the equation, considering this bulldozer method, we can say, being written as this can also be the 2y, the x squared plus p, the y, the x plus 2y is equal to 0. It means the solution is y is equal to c1 exponential of m1x plus c2 exponential m2x, whereby c1 and c2 are just arbitrary constants. Now that is the solution when that equation has got real and distinct roots. Part B, if b squared minus 4ac is equal to 0, then we shall have repeated roots. In other words, we will have something like m minus m is equal to m2 and it is equal to m. So if it is repeated roots, then the solution, the general solution, becomes c1x plus c2 cross brackets exponential mx. Now if they are complex roots, it means b squared minus 4ac is less than 0. It means therefore if we apply bulldozer method, m is equal to alpha plus or minus j b, whereby j is a complex number equivalent to square root of -1. The solution will therefore become y equal to exponential of alpha x, alpha is this number here, open brackets, a cos beta x plus b sine beta x. Now, for homogeneous ordinary differential equations of order 2, the general solution is what is always called the complementary or homogeneous solution, which can always be called yc or yh. So having understood that, we have talked about three cases. You must master them. We are saying if we have real and distinct roots, that is b squared minus 4ac is greater than 0. Then we have also repeated roots, where b squared minus 4ac is equal to 0. And we have also complex roots, where b squared minus 4ac is less than 0. So in the first case, we are saying y will equal to c1 e exponential of m1x plus c2 exponential of m2x. The second one will be c1x plus c2 into exponential of mx. If we look at the next one, it means y, if we have complex roots, it will be exponential of alpha x into a cos beta x plus b sine beta x. Thank you so much for watching. For us in the next lecture.